Well, hello there, young scientists. Welcome to today's Explainer. I am absolutely thrilled to have you here because today we're going to uncover a massive secret. You know what it is? Science is actually just kitchen magic. Seriously, it's totally true. Every single day, we're totally surrounded by popping bubbles, stirring spoons, and sparkly potions mixing all together. So today we're going to look really closely at exactly how we mix things together, and even crazier, how we can unmix them. So what do you say? Are you ready for an adventure?
Okay, let's just dive right into this. You know that bright, sparkly, white sugar in your kitchen? Have you ever stopped and wondered, hey, where does this stuff actually come from? I mean, does it fall from the sky like snow? Does it grow on trees in perfect little white cubes? Nope, it actually comes from tall, green, grassy plants. Isn't that wild? But how in the world do we take a green leafy plant and turn it into those sweet white crystals we sprinkle on our cereal? Well, it's all about how everyday things are actually magical mixes, just waiting for us to figure them out. Look right there. Do you see those tall, green sugarcane stalks waving back and forth in the wind? Watch closely what happens when farmers squeeze those plants. A sweet juice comes rushing out and flows like a zooming river straight into a massive cooking pot. In the real world, inside giant kitchens that we call laboratories, scientists use amazing tricks to take that exact sweet juice and somehow pull out the hidden white sugar pieces. It's quite literally a real-world magic trick of separating a mix.
But wait a second, not all mixes act exactly the same. Take a look at these two glasses. We've got a smooth mix right here. Look at how perfectly clear that water is as it spins around. You can't see a single thing hiding in there, right? It looks exactly the same from the very top to the very bottom. But now, compare it to the chunky mix right next to it. If you watch really carefully, you can see little brown mud particles sinking and tumbling all the way down to the bottom of the glass. Yeah, that one is definitely not smooth.
And this brings us to an absolutely super fun game of science hide and seek. When we make a smooth mix, we basically have a hider and a seeker. The hider is the stuff we drop in, like sugar or salt. In science, we actually call the hider a solute. The seeker is the liquid, like water, that wraps all around the hider. We call the seeker a solvent. When the hider is really good at this game, it completely disappears into the seeker. But, is there a sneaky way to cheat at hide and seek and find exactly where those tiny hiders are floating?
Well, this brilliantly shows off our ultimate secret weapon, the magic laser test. Check this out. We're shooting a bright red laser beam straight across the table. In that first clear glass of water, the beam just shoots right through, and you can barely even see it. The hiders are just way too tiny. But look at that second glass. It has just a little bit of milk mixed in. Wow, look at that. The milky water actually lights up. It's glowing red from the inside. The laser beam is bumping into those slightly bigger milk hiders floating around, lighting them up like tiny little flashlights. Now, sometimes scientists need to know exactly how much hider stuff is trapped inside our seeker liquid. To do that, we use 3 magical recipe rules to find a special magic score, which is called a percentage. So here is rule number 1, and we call it mass by mass. Imagine little toy blocks tumbling right into our mixing bowl. This rule simply means we weigh the solid stuff we're dropping in, we divide it by the weight of the entire finished mix, and then we multiply by 100 to get our magic score.
Okay, let's play with some actual numbers for a second. Imagine you have 10 bouncing scoops of salt. You take those 10 scoops and you toss them into 90 scoops of water. Well, 10 scoops of salt plus 90 scoops of water gives us 100 scoops for our whole bowl, right? So what's our magic score? Since 10 out of the total 100 scoops are salt, our magic score is 10%. Boom! That tells us exactly how salty our magic water really is.
All right, let's move right along and see how this builds into our second rule. This one is called mass by volume. Now, instead of weighing absolutely everything, we weigh the solid hider stuff, but then we look at how much space the swirling liquid pool takes up. We divide the weight of the stuff by the amount of liquid space in the whole mix, and then, you guessed it, multiply by 100. It's kind of like dropping a heavy solid weight right into a spinning, splashing pool. Let's look at a magic example for Rule 2. Imagine 5 glowing pieces of sugar splashing right into a measuring cup. The cup fills up to exactly 100 little liquid drops, which scientists call milliliters. Because we dropped 5 glowing pieces into a total space of 100 little drops, our magic score is exactly 5%. It's basically just saying, out of 100 drops of space, the sugar brings 5 pieces of heavy magic.
And now for our final recipe rule. Rule 3. This one is called volume by volume. This is for when we mix 2 liquids together, just like a wizard mixing up a beautiful, bubbly potion. Do you see how those two different colored liquids swirl and dance together? For this rule, we see how much space the first liquid hider takes up, we divide it by how much space the whole wizard potion takes up at the very end, and yep, multiply by 100. Okay, do you see that single, tiny, little drop of orange juice? Watch it dive. Splash! Straight into that giant cup of water. Now, if that giant cup holds exactly 100 drops of liquid total, and only one of those drops was our dancing orange juice, then our magic score is exactly 1%. This is super helpful when you want to make a glass of water taste just a teeny tiny bit like fruit.
But hold on a second. How much stuff can water actually hide before it gets completely, totally full? Well, let me teach you the full tummy rule. See that blue glass? That's freezing cold water. Cold water is kind of sleepy. It can only hide a little bit of sugar before its tummy is totally full, and the sugar just starts sitting at the bottom. But look at the red glass. That is hot water. Hot water is totally awake, hyper, and super hungry. It actively gobbles up way more sugar before it gets full. Hot water can hide so much more stuff.
So here is the absolute crucial point. How do we get the sugar to come back out of the water after it hides? We use the ultimate unmixing magic trick called crystallization. Here is how we do it. Step 1, we make the water super hot and feed it as much stuff as its hungry tummy can hold. Step 2, we pour it through a tiny paper filter to catch any dirty chunks. And step 3, we just let it sit, relax, and cool down super slowly.
And you know what happens when we let that hot water slowly cool down into sleepy, cold water? Magic happens. Because cold water has a tiny tummy, it has to spit the hiding stuff right back out. Look at these amazing, shiny blue crystals made of something called copper sulfate. If you watch them closely, you can actually see them actively growing, expanding, and sparkling bit by bit. As the water cools, all those hidden pieces grab onto each other, stacking up like perfect geometric building blocks to make these absolutely gorgeous, glowing blue rocks.
Now, what's genuinely amazing here is that Mother Nature does this exact magic trick all by herself. Imagine a freezing cold window pane. When invisible water floating in the air gets really cold really fast, it decides to stick together. Do you see how those icy frost crystals are actively crawling and stretching like beautiful frozen spider webs all across the glass? That is the exact same unmixing magic we just talked about, happening right outside your own house.
Wow, we have learned so much today, haven't we? We learned all about smooth mixes and chunky mixes. We learned how to find the magic score for our recipes using rules. And we learned how hot and cold water can hide or even spit out glowing crystals. Science is quite literally everywhere around you, just waiting to be discovered. So, I have one last big question for you. The very next time you pour a glass of lemonade or watch a pot of soup bubbling on the stove, what magical mix are you going to explore in your kitchen today? Go out there and be amazing kitchen scientists. Catch you next time.